second session of full microeconomics revision. Now, as all of you, as I just confirmed this morning also, you may be aware that I had given you the first numerical sheet to be done with the session that I had taken. And I hope that all of you have done that numerical sheet. If not, then the first thing that you do today after this session is go through those numericals that I had given in the last marathon. The solution to those numericals are also posted on the portal only under microeconomics section. Towards the last, you will see the solution of those numericals also. So all of you have to go ahead and do those numericals. Now, the second thing which is important is that today again, I have gone ahead and I have prepared a numerical sheet. This has a lot of numericals in it, and all of you are supposed to do these numericals today itself. This is very, very important for the preparation of our MA Economics entrance exam. So all of you will go ahead and prepare these numericals. I will go ahead and upload the solution also just below the numerical sheet after today's session. And, I hope that you will definitely attempt these. Now, I hope that all of you have also got the second, revision notes. And I think they have been already posted on your Telegram group. Can you just confirm me once? Just say a yes or no if you have them on the group. Okay, great. So you can just use these notes for the second part of microeconomics revision. Okay, good beta. Let's start then. So just read this through and I will just come to ICC and angel curve directly. So now just try to understand that whenever we talk about the type of goods, we can divide the type of goods in three parts. तीन तरीके की goods हो सकते हैं. It can be a normal good. It can be an inferior good. And it can be a given good. Now, both of these, they obey the law of demand. And this is an exception to the law of demand. So what can come in exam, mathematically bhi aa sakta hai, they may ask you, derive the equation of angel curve or derive the equation of your demand curve. Or they may ask you, derive the equation of income offer curve or price offer curve. Like that, they can ask you in exam. They can give you 4 options and they will ask you, what is the equation? Which of the following represents the equation of the angel curve? So in this case, we have to be very sure that when I am talking about my income offer curve, this is showing different combinations as your income is increasing. So I have my budget line and I have my indifference curve and I have this as my equilibrium. This is my equilibrium. Now, when my income increases, my equilibrium will go upwards. Joining these equilibrium points, I will get my income offer curve. So I am joining different equilibrium points now. And how do I represent this equilibrium point? This equilibrium point is where my MRS is equal to PX by PY. So I am joining the locus of all these tangent points, right? That is giving me my income offer curve. And if I just go ahead and I take income on one side, एक side पे मैंने सिर्फ income ले लिया, and I take the demand of the good on the other side, then what will I get? I see that if it is a normal good, then the demand of the good will increase as my income increases. So I will get an upward sloping angel curve. Angel curve क्या बता रहे बच्चे? It is telling me different combination of income and demand है ना? So when income is M1, your demand is X1. When income is M2, your demand is X2. यही तो एंजल कर्व बता रहा है. So if you remember, let's say I have a utility function XY. We know that if the utility function is XY, तो बच्चे what will be X star? It will be M by 2PX. What will be Y star? It will be M by 2PY. So we know that X is actually a function of income. And from here only I can see that when my income will increase, income numerator में आ रही है, as my income will increase, the demand of X will increase. So this also guides me to the fact that X is a normal good. Because as your income is increasing, your demand is increasing. Acha, now just think about it. Suppose I have income here and I have X here. And question में वो पूछ लेते हैं in exam that find the slope of angel curve. तो angel curve क्या बता रहा है? Angel curve is giving you the equilibrium combinations of income and good. So the slope of this angel curve will be nothing but change in perpendicular by change in base. Change in perpendicular will be what? How income changes. Change in base will be what? As X changes. So ideally, अगर मेरे पास मेरा equilibrium bundle है, if I have this equilibrium bundle, then can I not just go ahead and find dm by dx from here? That will be the slope of the angel curve. So such questions can be asked in exam. They can ask you find the slope of angel curve, find the slope of the demand curve. Demand curve hoga, then I am plotting it between price and X. So iska slope will be dp by dx, right? So they can go ahead and ask you the slopes of angel curve, demand curve, and you should be aware कि कौन सा curve कौन से कौन से x axis and y axis coordinates पे plotted है. What am I taking on the x axis? What am I taking on the y axis? Another thing that is important here is what happens. So I have been seeing this doubt a lot. What happens to price offer curve for normal, inferior and given goods? Price offer curve के बारे में, right? Just think about it. But this is a very tricky question for normal goods. समझो जरा ध्यान से. If I have this as my budget line, AB is my budget line, and I draw one equilibrium point. मैंने यहाँ पे अपना equilibrium point draw कर दिया. Point E is my equilibrium point. Now, the question tells me that price of good X has decreased. It means that my budget line will pivot outwards. Budget line बाहर की तरफ चली जाएगी. If my budget line will pivot outwards, then if it is a normal good, I know I have to increase the demand of good X. मुझे X की demand को increase करना है. I have to increase the demand of good X. But this is where the issue lies. क्योंकि just notice here, beta, if I draw my new equilibrium point here at E1, then also I have increased the demand of good X. ध्यान से notice करो, demand of good X has increased. So price of good X decreased, demand of good X increased, fine. Now just think about it. What if I go ahead and draw my equilibrium point at E2? Then also I've increased the demand of good X. ये भी ठीक है. What if I draw my equilibrium point at E3? Then also I've increased the demand of good X. So whether I go from E to E1, I have increased the demand of good X. Whether I go from E to E2, I have increased the demand of good X. Whether I go from E to E3, I have increased the demand of good X. So beta, that ways, अगर मैं इनको join करती हूँ different points को, what will I get? Well, if I join this, I will get upward sloping price offer curve. If I join this, I will get horizontal price of a curve. If I join this, I will get downward sloping price of a curve. In exam, if they ask you that the price of a curve of normal good is, please don't write upward sloping. हमेशा upward sloping नहीं होता है. तीनों ही केस में when the price has decreased, I have increased the demand of good X. It is obeying the law of demand. But in all the three cases, I see that the shape of the price of a curve that I get differs. तीनों में price of a curve का जो shape बन रहा है, that is different. Right? So this is very tricky and you should be well aware of it. बाकी given goods में the price of a curve becomes backward bending. Right? And inferior good, so they also obey the law of demand. So when price of this good will decrease, its demand should increase. We don't have any issue there. But only here, for given goods, it will be backward bending. That is another thing that you have to remember. ये चीज भी याद रखनी जरूरी है. So that is it that I have here. Then beta here just come to this box. Equilibrium will occur where slope of IC is equal to slope of budget. That's correct beta. But वो new indifference curve कहाँ पे होगा वो तो differ कर सकता है ना. So my new indifference curve can pass through E1. My new indifference curve can pass through E2. My new indifference curve can pass through E3. नया IC कहाँ होगा, that can be different ना. I am joining the equilibrium points only, जहाँ पे ये tangency है. That is what I am doing. But वो indifference curve, where that will be, that can differ. Right? So accordingly, I can get different POCs. Is that clear now? Okay. Okay. Now this box I have explained you last time, so I'm not repeating this box again. Just go through it. Acha, now this is very, very important, and I have given you a numerical on this also. This is what is compensating variation. Versus equivalent variation. In very, very simple terms, ध्यान से समझ लेते हैं एक बारी बेटा. Compensating variation keeps utility at original level. Just for example, I have given this example multiple times in live class. There is this individual. This individual is living in city A. He has a utility function. City A में price of good X is given to you. Price of good Y is given to you. You are given his income. अब क्या हुआ? His company, he told him that we are transferring you to city B. हम आपको city B में transfer दे रहे हैं. In this city B, जिस city B में अब वो रहेगा, in city B, his utility function is same, जो भी आपको दिया होगा, but city B is very expensive. जैसे imagine, if this person goes from say Delhi to Bombay, and Bombay is expensive, Bombay ज़्यादा महंगा है, it's expensive. The price of good has increased. It has changed. It has increased. So, suppose यहाँ पर after consumption, his utility was 2,500. Now, if the price of this good has increased, this city is expensive, it means that he will be able to afford less goods. कम खरीद पाएगा. If he will be able to afford less, his utility will decrease. उसकी utility भी गिर जाएगी. Now, this person is worse off. He doesn't want to go to city B. So what will this company do? This company will say, okay, you go to the city B, but I will give you some additional income. मैं आपको कुछ और पैसा दे देती हूँ. But, you know, I will make sure that you get the same level of utility. if you were getting a utility of 2500 here, अगर आपको 2500 का utility यहाँ मिल रहा था, I will ensure that you get the same utility here, even though this city is expensive. This is called as compensating variation. The extra income that this person will get, जो उसको extra पैसा मिला, the extra income he will get. Why will he get extra income? Because city B is expensive and he wants the same level of utility. उसको same utility चाहिए जो पहले मिल रही थी. The extra compensation he will get, that is called as compensating variation. Am I clear with this? I have given a numerical on this concept using the same example. Everyone will try that. So compensating variation says the extra money you are getting ताकि आपको same utility मिल पाए, so that you can get same utility as before even when prices have increased. That is called as compensating variation. So we are holding utility at the old level. हम यूटिलिटी को ओल्ड लेवल पे कंसिस्टेंट रख रहे हैं, कांस्टेंट रख रहे हैं. इक्विवेलेंट वेरिएशन विल डू द ऑपोजिट. इक्विवेलेंट वेरिएशन विल होल्ड यूटिलिटी एट न्यू लेवल. राइट? इट विल से अच्छा ओके, सिटी बी में अगर सिर्फ 2400 की ही यूटिलिटी मिलती है तो सिटी ए में 2400 के लिए इसकी इनकम कितने से कम करें? हाउ मच शुड हिज इनकम बी रिड्यूस्ड सो दैट ही गेट्स द सेम यूटिलिटी एट द एज द न्यू लेवल, सो दैट ही इज इंडिफरेंट कि यहाँ पे भी इसकी पैसा गिरा दो ना, अब तो ही विल बी रेडी टू गो टू द न्यू सिटी. दैट इज इक्विवेलेंट वेरिएशन. सो इन कॉम्पनसेटिंग वेरिएशन you will hold utility at the original level, right? Even at new prices, you want him to get the old utility. So you will go ahead and give him more money when price will increase. In equivalent variation, you will hold utility at the at the new level. I hope this is clear to you. I have provided a numerical, please do that. So this concept, beta, it is explaining you compensating variation only. Now come below, just come below. And here I want to talk about risk before I go further. Okay. Now just listen to me. In risk, you should be aware of the following concept. Pehla, you should be aware about expected value. That's the first thing that can be asked in exam. Expected value बहुत basic है. If I tell you that the probability of accident is 10% and under accident you will get 0 and the probability of no accident is 90% and no accident में you will get 10,000, find expected value. ये पहले तरीके के क्वेश्चन हो सकते हैं. So 10% into 0 plus 90% into 10,000 and you will get expected. The second kind of question that can be asked in exam. Okay, beta, towards the last I will show you a numerical on CV and EV. Okay, I will take you through that numerical sheet question. Don't worry. Just remind me towards the end. Okay, so this is expected value. Then the second kind of question that can be asked in exam is expected utility. So expected utility mein you will be given a utility function and you will be asked to calculate expected utility. तो उसमें क्या होगा ना? So if I were to find expected utility, I will be having 0.10 root 0 plus 0.90 root 10,000. That's the second kind of question. Now, post this, if you remember, we did a concept of risk premium. And हमने ये बोला था कि risk premium is that amount which a consumer is willing to give in order to avoid risk. जो पैसा वो risk से बचने के लिए देना चाहता है, the amount he is willing to give in order to avoid risk, that is called as risk premium. In this concept of risk premium, we did three kind of individuals: risk averse, risk lover, risk neutral. And we said that if an individual is risk averse individual, मतलब वो तो risk definitely avoid करना चाहेगा, he wants to avoid risk. So for this individual, the risk premium will be positive. He will give you money in order to avoid risk. वो बोलेगा मुझसे पैसा ले लो, but I don't want to take risk. A risk neutral person will have zero risk premium. He is neither willing to give money nor does he need money. And a risk lover individual will have negative risk premium. Why? Because he wants to take risk. तो अगर आपको उसको रिस्क लेने से बचाना है, you will have to give him money if you want him not to take risk. So we talked about the concept of risk premium, where we said why risk premium can be positive, negative or zero. इसकी हमने बात की. Now, the next thing that can be therefore asked in exam is calculate certainty equivalent. Right. Again, I want you to practice numerical sheet today itself. There is a question on certainty equivalent in the numerical sheet. What was certainty equivalent saying? Certainty equivalent says that, look, if a person is taking risk, then he is getting some utility. मतलब मैंने risk लिया, आपने मुझे बोला, look, you have to go in this house and this house may fall and you know there is 10% chance you may die. Then also I went into this house. So when I am taking risk, I am getting some utility. Say my utility is 50. There may be a corresponding situation when I don't take risk and I get the same level of utility. What is that money which will give me the same level of utility as this? That is what certainty equivalent says. तो हमने इसको कैसे calculate किया था? I will just show you through this example. If you remember, this was my curve. ये हमने एक curve बनाया था. And then we said, look, this is two scenarios. ठीक है, एक में आपको कुछ money मिल रहा है, दूसरे में कुछ मिल रहा है. We had gone ahead and taken its weighted average and we had got up a bundle here. This was called as the weighted average bundle. We were getting some utility from this and this was called as expected utility. That money which gives you same utility as this expected utility, but that money is certain. यहाँ पर जो पैसा है जो आपको सेम यूटिलिटी देता है एज एक्सपेक्टेड यूटिलिटी, दैट इज कॉल्ड एज सर्टेनिटी इक्विवेलेंट. आई होप यू रिमेंबर दीज कॉन्सेप्ट्स. सो सर्टेनिटी इक्विवेलेंट वर्ड में आ रहा है, दिस इज द सर्टेन अमाउंट, फिक्स्ड अमाउंट दैट गिव्स यू यूटिलिटी इक्विवेलेंट टू एक्सपेक्टेड यूटिलिटी. राइट? So you will find your expected utility first. And then you will say कि ठीक है, if my expected utility is coming as 400 and my utility function is root of W, so which wealth will give me 400 with certainty? You will just equate root W to 400 and you will get W as 400 square. This amount will be called as certainty equivalent. ठीक है. So we are saying कौन सा ऐसा पैसा होगा जो same utility दे as expected utility. This is very important from exam point of view and this will come in exam 150%. Then the next thing that can be asked in exam from this chapter is to find out insurance premium. But please revise this chapter as many times as possible. It's an important one. And actuarially fair insurance. So we had said that, you know, fair का मतलब ये है that you will pay premium equal to probability of loss into size of loss. This is the formula for actuarially fair insurance. So for example, if I tell you that there is this person and there he can get heart attack 10% of the time. If he gets heart attack, he will not be able to work and he will lose 50,000 health. 90% of the time he will not have any heart attack and his wealth will be say 2 lakh. And the question is asking you calculate actuarially fair insurance premium. ऐसा कुछ बोल दिया कि actuarially fair insurance premium निकालो. So actuarially fair insurance premium will be probability of loss. Beta, what is the probability of loss? 10% of the time. And the size of the loss. So मेरा loss कितना हो रहा है? My wealth is 50,000 when I fell ill. My wealth is 2 lakh when I am fine. So I am losing 1,50,000 now when I am ill, when I am sick. So my size of loss is 1,50,000. When you will multiply the size of loss with the probability of loss, that will give you actuarially fair insurance. बहुत important है. एक simple just दो numbers को multiply करके answer आता है. It's an easy calculation problem. Therefore, it can be asked as part of MCQ. It can come in exam. So we have to be very sure of this concept. These are few of the concepts. Plus, there is an assignment on uncertainty. Jisme there is a question on ArrowPrat. Please do that assignment and do this ArrowPrat. Know the formula of ArrowPrat also. हाँ? वो risk aversion calculate करने का formula and write down. इसी पे कहीं पे write down in your registers that you have to read that assignment question and do this ArrowPrat numerical. Okay, now just come, please do these things today itself, beta. We don't have enough time to revise this again. इसके बाद दोबारा time नहीं मिलेगा that you open up micro because I will move on to the next subject. So it is very important that you do this with me. Now we talk about production theory. So production में law of variable proportion, law of returns to scale. Returns to scale is a long run concept. Variable proportion is a short run concept. Now you can just go through this. This just says that as you increase your input, the output, marginal output decreases. That means marginal product of labor is diminishing. ये बोल रहा है. You can just go through this. This is basic. I want to talk about this. This will come in exam. Important. Very, very important. देखो, all of us are aware about the 3 returns to scale. So we know that when it is increasing returns to scale, if you will scale your labor and capital, then your output will scale more than alpha. ये हमें पता है. जैसे example, if I take my production function as L square into K, तो जब मैंने labor और capital को double किया, my new output will be 8LK. So it will be 8 times the 8L square K. So it will be 8 times the original level of output. I only doubled my inputs, but my output became 8 times. This is increasing returns to scale function. ऐसे हमें constant returns to scale and decreasing returns भी we are clear with it. So constant returns to scale will look something like this. Y is equal to L to the power half, K to the power half. And decreasing will look like this. L to the power 1 by 4, K to the power 1 by 4. You can also see by adding the powers. The sum of the power is less than 1. So this is decreasing returns to scale. Equal to 1, constant returns to scale. Greater than 1, increasing returns to scale. But in exam, they will go ahead and they will ask you question related to the gap of isoquants based on the returns to scale. They will ask you, suppose this is an increasing returns to scale function. ऐसा कुछ दे देंगे. Suppose it is increasing returns to scale, then the isoquants will be equigap, less gap, more gap, something like that. ऐसा कुछ question आ जाएगा. So this is important that if it is a constant returns to scale function, your isoquants are equidistant. Please mark this important in your sheets. If it is decreasing returns to scale, the distance increases. Decreasing returns to scale, isoquant distance increases. Increasing returns to scale, isoquant distance decreases. Please take out a printout of this sheet and write down important here, beta. This is very important. 150% I can tell you in one of the entrance exam, this MCQ will be asked. Okay. Then we know what an isoquant is. The slope of isoquant is MRTS. This is nothing but MPL by MPK, right? And beta, jab bhi MPL by MPK likho, make sure that you know L is here and K is here, right? So just remember that by default, when I take capital on y-axis, that is when I will have marginal product of labor in the numerator. That's also important. Okay, now come to the next sheet. Just like the elasticity, just like the indifference curves, isoquant can also have this function. मतलब ऐसा कुछ हो सकता है that Q is equal to min of LK. Q is equal to alpha L plus beta K. So you can have labor and capital complementary. You can have labor and capital as substitute also. Now here, another kind of question that can be asked in exam is this. Find output elasticity of input. Just for example, they give you a function like this. Q is equal to 10 LK. They're asking you find output elasticity of labor. हाँ बेटा. To do this question, there are two ways. दो तरीके हैं इस question को address करने के. Number one, I use the definition. So this is saying output elasticity of labor. मतलब how output changes as labor changes into initial value of labor by initial value of output. ये elasticity का formula है. I am just using this formula. So if I differentiate this with respect to L, I will get 10K into L by Q. तो ये हो जाएगा बच्चे 10 LK by Q, Q by Q, 1. एक तो ये तरीका हो गया, simple. I am just using the basic formula of output elasticity of labor. Second formula. It is asking me calculate output elasticity of labor, and it can be calculated using this formula. Marginal product of labor divided by average product of labor. ठीक है, वो करके देख लो. You will get the same answer. What will be marginal product of labor? Differentiate this with respect to L. Differentiate this with respect to L. This will give you 10K. What will be average product of labor? Output divided by labor. This will be 10 LK divided by L. That means 10K. So what will be MPL by APL? It will be 1. Divide this by this. You will get the same answer. So both of them are giving you the same answer. Sometimes in exam, they will just ask you this formula. So this formula is equally important, that the output elasticity of input is MPL by APL. This is very important and you should be aware of this. Okay. Then you have a homogeneous function. Any function जिसमें हम scale करके factor को बाहर निकाल पाएं, m को बाहर निकाल पाएं, that's a homogeneous function. Then in exam, isn't it simply the power of L here? So, if you go ahead and you look into it, you can also go ahead, correct, that's right. You can also go ahead and you can also look by looking into the powers. And you can go ahead and say that that's the power. Absolutely, that's also correct. There is nothing wrong in it, correct. Can it be in terms of capital? Yes, yes. In any input, किसी भी input के लिए you can go ahead and find it in terms of capital. This can be MPK by APK also. If you have given, अगर land दिया हुआ, it can be MPT by APT. Any factor you are given, correct. So because you highlighted that it can be power of labor or capital, I just want to highlight that, that is only possible if it is a Cobb-Douglas function. But what if it is not Cobb-Douglas? What if I'm given some other kind of function? What if I'm given this, that Q is equal to LK plus L? Then I have to go ahead and calculate, right? So then this formula is very handy for me to go ahead and solve. Okay, beta. Okay. Now let us go ahead and let us talk about the Cobb-Douglas production function. The Cobb-Douglas, this can come just as part of GATE or CUET question, that it was first introduced in 1928. And then you just have to remember that, the Cobb-Douglas production function, generally, whenever I write this, I will write it like this. L to the power alpha, K to the power 1 minus alpha. This is the initial production function we had. So if I write it like this, then you can clearly see that it is a CRS function because the sum of the power is 1. And as I have written here also, alpha tells the output elasticity of labor and beta tells the output elasticity of capital. So ये काफी important हो जाता है that you go ahead and remember these properties. These are some of the other properties given of Cobb-Douglas function. Please read through them. They are very, very important from the point of view of exam. This has been asked multiple times in exam, and we should be well aware of the Euler's theorem. So Euler's theorem, what does it suggest now? The Euler's theorem goes ahead and it suggests that if I have any production function as a function of labor and capital, then I can go ahead and I can, just think about it. If I do a total differentiation of this function, I will get dq is equal to del f by del l dl plus del f by del k dk, right? And but del f by del l, this is telling me how my output changes as labor changes. This is marginal product of labor, dl. This is telling me how my output changes as capital changes. This is marginal product of capital, dk. And this is equal to dq. Right. Now, if I just go ahead and I use this fact here, एक और चीज है. So if you're given this production function, for Euler's theorem to hold true, it must be sure that it is a homogeneous function. Otherwise, I won't be able to go ahead and I won't be able to apply this Euler's theorem. So now, once I have gone ahead and got this, what I can go ahead and do is divide throughout by 1. So I will get dq by dq is equal to mpl dl by dq plus mpk dk by dq. And because this is a homogeneous function, when you will be solving this, you will end up getting this equation. You will end up getting, I have done this in live lectures also, you will end up getting MPL into L plus MPK into K is equal to Q. This is very important from the point of view of exam. Very, very important. But this is only going to hold true if you have a linear homogeneous production function. It is not holding true if it is a non-linear or non-homogeneous production function. Only if it is linearly homogeneous production function, only then my Euler's theorem will be holding true. Take an example to solve this. Let's say my Q is equal to L to the power alpha, K to the power beta. I just find out marginal product of labor, del Q by del L. It will be alpha, L to the power alpha minus 1, K to the power beta. This is marginal product of labor. Now what do I do? I just go ahead and multiply this with L. So L into MPL, this is going to be L, this part MPL into L. So this will be alpha K to the power beta into L to the power alpha. This will be alpha times Q. So if I do L into MPL, I'm getting alpha times Q. Similarly, what I can do, I can just go ahead and find out del Q by del K. If I differentiate this function with respect to K, क्या मिलेगा मुझे बेटा? Beta K to the power beta minus 1. This is nothing but MPK. If I do K times MPK, I will go ahead and I will get L to the power alpha beta K to the power beta minus 1 into K. So I will get beta L to the power alpha K to the power beta. This will be beta into Q. Now I just have to add. So L into MPL plus K into MPK will give me alpha into Q plus beta into Q. This will be Q times alpha plus beta. And if it is a CRS function, constant returns to scale function, agar power alpha plus beta 1 hua, then what will I get? I will simply get Q into 1. That means I will get Q. So if I have a linearly homogeneous function, matlab CRS function, constant returns to scale function, then for constant returns to scale function, this equation holds true, and this can be asked very well in the MCQ. That MPL into L plus MPK into K is equal to Q. Then it will not hold true. Just I just showed you this example, na, that if you go ahead and you see that your production function is non-homogeneous. Just for example, beta here. I mean, non-linear. Just for example, if your alpha plus beta is 2, then it will be 2 times output. Alpha plus beta 2 ho raha hai. If your alpha plus beta is just half, then it will be half times the output. Only when it is CRS production function, you will get exactly Q. Okay. Then this is the CES production function. You must remember that this CES production function was given by Arzoo, Minhan and Chenery. It was given in 1961, and this is the but it will still hold true if it is a non-Cobb-Douglas production function, but it should be homogeneous, right? It should not be non-homogeneous. But quasi-linear production function mate will not hold true because it is a non-homogeneous production function. Okay. This is not specifically for Cobb-Douglas. It should be homogeneous of degree 1. That means it should have constant returns to scale. Then this equation will hold true. So yeah, so I told you, right? If it is increasing returns to scale, तो हमें यहाँ पे दिख रहा है ना that I am able to take beta alpha plus beta common. So when it is increasing returns to scale, तो alpha plus beta की जो sum होगा, it will be more than 1. तो suppose 2 हो गया sum. So it will be 2 times Q, or it will be 3 times Q, and so on. So if alpha plus beta is greater than 1, accordingly you will go ahead and you will have Q this year. Absolutely, you're correct, beta. So you can go ahead and write this as K times Q, where K represents the degree of homogeneity. Correct. K is the degree of homogeneity. So your equation becomes L into MPL plus K into MPK is equal to K times Q. If it is a constant returns to scale function, degree of homogeneity is 1, K is 1. So you can just replace it with 1 here. Okay. Fine. Let's continue. Now, we have gone ahead and done this also in class. यहाँ पे एक चीज देख लेना बेटा. It's a constant returns, constant elasticity of substitution production function. So in this case, what will happen is that your elasticity of substitution, it will come as 1 upon 1 plus beta. If you look into our lectures that we have done, beta ki jagah na I have used rho, right? So you have to be well aware. Please write this down here itself, that read the constant elasticity of substitution production function and try to know the relationship between rho and sigma. Rho और sigma का relationship you should be well aware. So everyone will revise that. So we have done this कि अगर rho 1 होगा तो sigma क्या होगा और ये कौन सा production function represent करेगा. You know, if your sigma is 0, then it represents your complementary goods. Or if sigma is infinity, it represents which good. ऐसे करके, right? It represents your substitute good. So for different elasticity of substitution, which kind of production function it represents, you have to read that lecture thoroughly. So please do write here, revise this concept with relation between rho and sigma. ये करना जरूरी है. Okay. Now, next thing that I want to talk about is different kind of savings. So, so beta, this is something that I have done it in the recordings. Just have a look here. We have derived this. It's a big derivation. You will go ahead and you will get the relationship between rho and sigma. Sigma represents the elasticity of substitution. And rho was representing the power of the CES function. So we got that sigma is equal to 1 upon 1 plus rho, right? And then we said that if your rho is say 0, then your sigma will be 1. And when sigma is 1, it represents the Cobb-Douglas production function. Similarly, when your sigma is 0, that means there is no substitution possible between two inputs. Elasticity of substitution is 0. So if no substitution is possible between inputs, that means these are complementary inputs, right? So like this, we took 3 cases. Sigma is 0, sigma is 1, and sigma is infinity. Just make that table and revise. Yay values actually, huh? Okay. Now we want to talk about the technical process being neutral, labor saving, and capital saving. When I say that it is a neutral technical progress, it means that your production function will look like this. A, L to the power alpha, K to the power beta. It is a neutral technical progress. Matlab technology will increase, but it will help us to go ahead and use the same amount of inputs I was using earlier in the same ratio. It means if I was using labor and capital in the ratio of 2:1, I will continue using labor and capital in the same ratio. It will not hamper my ratio. This is what neutral means. But when I talk about labor saving technical progress, then labor saving technical progress, as the word suggests, it means that after technical progress, you will be using less labor per unit capital. It means if earlier I was using 2 labor per unit capital, now I will be using 1 labor per unit capital. I will be using less labor, right? So this is what a labor saving technical progress is. Similarly, a capital saving technical progress means I will be using less capital afterwards. So, you know, if earlier my labor to capital ratio used to be 2:1, now I will be using even less capital. So it can be 2:, say, 0.5. So capital saving technical progresses when you go ahead and you will be using less amount of capital. That becomes a capital saving technical progress, right? Now, if I talk about ridge lines, okay. So these lines are doing exactly the same thing. So देखो यहाँ पे, say suppose example लिख लूँ. Say I say that labor to capital ratio initially, say it is 2:1, right? And the new labor capital ratio is 1:1. Less labor is required. This means it is a labor saving technical progress. Now just think about it. If I draw, if I have to show any ratio, I can show that ratio by passing a line through the origin. So just see this. पहले बोल रहा है कि when I have, this is labor, this is capital. First, it says that 2 labor with 1 capital. So 2 labor with 1 capital. That means this was my line. Right? L is to K was represented with this line. Now it says 1 labor with 1 capital. So my new line becomes this. It becomes steeper. Right? This is what this is showing. So just see here. Just see here. Now your initial line is when you have comparatively flatter, and the new line is when you have steeper. Input saving has no relation with returns to scale. Correct. The two things are different. The two are not related to each other. Right. So what will happen is, if initially my wherever I was drawing my isocont, if initially my isocont had this point, right? This is where I was. Then now I have to be on this labor saving line. I have to be across a line wherever I was reaching my equilibrium. That equilibrium will be reached on the new line, such that this new line, it represents the ratio of 1:1. So my new isocont equilibrium, it will be on this line. This point will be my equilibrium. I have to be at a point such that I am across this new labor capital ratio line. And how do I show these labor capital ratios? I represent them through line or ray through the origin. This is what this means. So you just have to go ahead and see, if I am becoming labor saving, it means that with time I will be going towards more steeper lines, because I will be using less and less labor for the same amount of capital. If I am using capital saving lines, it means I will go for flatter lines. I am using less and less of capital for the same amount of labor. Then the next concept is that of a ridge line. So when we talk about ridge line, this can again be asked as an MCQ. Please remember this. Ridge line is the locus of those points where marginal productivity of at least one factor is 0. अब ध्यान से देखो, if you remember, when we take one factor at a time, I had drawn total product curve like this. And across this total product, we had drawn marginal product curve here. This is the point where marginal product of labor was becoming 0. And this is the point where my total product was becoming maximum. Of course, this was just in one input. ये सिर्फ एक input पे था, labor के input पे. Holding capital constant. ऐसे I can draw it for capital also. Those lines which represent that where the marginal product of at least one factor is becoming 0. सिर्फ इतना ही याद रखना है आपको. You don't have to deep dive into it. But those lines, the locus of those points where the marginal productivity of at least one factor becomes 0, that is called as the ridge line. Now, this is something you will do as part of your master's program. I have just plugged this in. This is not taught at bachelor's level, but suppose there is a small MCQ on this, you should just remember that the optimum stage of production is always between the two ridge lines. I draw a ridge line representing marginal product of input A as 0, representing marginal product of input B as 0. Only what is between these two lines will be my optimal region of production. You will do this in your MA classes. This is not a BA syllabus. Just that if at all they will ask you, they may ask you the definition of ridge line, or they may ask you just one of this concept. इसके ऊपर इसमें से कुछ नहीं आएगा. Now, another thing which is important, which we have already done multiple times in exam, in our classes, this is elasticity of substitution. अभी मैंने आपको explain भी कर दिया है sigma का value. So, just remember, when I have this isoquant and I go from one point to another, suppose I have this as point A and this as point B, then just remember that when you go from one point to another, two things are changing. एक तो इसका slope change हो गया. See, यहाँ पे steep है, यहाँ पे flat है. So the first thing that changes is MRTS. MRTS is changing. The second thing that changes is the ratio of labor and capital. So if I take L here and K here, and if I draw a line through the origin, I just explained you that ray tells me labor capital ratio. तो यहाँ पर अलग labor capital ratio है, यहाँ पर अलग labor capital ratio है. So when I move across an isoquant, two things are changing. It is, what is changing? One, the labor capital ratio is changing. And second, what is changing? MRTS is changing. Now, when we talk, just coming back to this point, just come a little backward. When I talk about this elasticity of substitution, it tells me how the MRTS changes as this ratio changes. What is the ratio between the two? That is what is told by the elasticity of technical substitution. And this is another formula of this. This is how it is written. तो ध्यान से देखो बेटा, this part, this is telling me percentage change in capital labor ratio, and this part, it is telling me percentage change in MRTS. So when I am moving from one point to another, capital labor ratio is changing, the slope of the isoquant is changing. इन दोनों में एक की वजह से दूसरे में कितना चेंज आ रहा है, that is what elasticity of technical substitution tells you. Okay. Now, there is also sometimes a question on ISO revenue line. बहुत simple है. Whenever you will see the word ISO, you will always resemble it with equal. फिर उसके आगे कुछ भी लिखा हो, ISO cost हुआ, same cost. ISO revenue, same revenue. ISO profit, same profit. So when I say ISO revenue line, it is a combination of those goods which generate equal amount of revenue. So if two goods give you same amount of revenue, that gives you the ISO revenue line. That is it that you have to do from here. Just come a little below. This we know. This is just MRTS is equal to the slope of ISO cost line. तो ISO cost line का slope होता है W by R. MRTS is MPL by MPK. So this becomes my producer's equilibrium. Come a little below. When I joined all such equilibrium points, it gives you expansion path. So for example, I tell you that this is my ISO cost line, and I tell you that this is my ISO quant. This is my equilibrium. Now, the producer has more money, so he can incur more cost. So his ISO cost line shifted upwards. And then his new equilibrium point is here. This is his new tangent point. If I joined all such tangent points, I will get the expansion path. This is my expansion path. So this is what this is explaining. Right? Okay. ये definition एक बारी बेटा देख लेना. Technical efficiency says that you are maximizing your output subject to given inputs. And economic efficiency says that you are minimizing your cost subject to given level of inputs. This is just a term. So if you see the word technical efficiency, you will be maximizing your output. If you see the term economic efficiency, you will be minimizing your cost. It is like income offer curve, correct? But it is for the producer. Okay, please try this question. ISO cost line we have done. Okay. Now just come to cost theory. So in cost theory, beta, explicit cost matlab ki bahar wala cost you are incurring on your labor, on your capital, the rent you are paying. Implicit cost means cost that is accounted for the services of the owner himself. So if I am working in my institute, the money I could have earned by working outside, that is my implicit cost. Explicit cost plus implicit cost is called the economic cost. The cost of next best alternative is called the opportunity cost. यहाँ पर कभी कभी in exam, they may ask you what is historical cost and what is sunk cost. So just remember these two. Historical cost is the original price of the factor. This is factor of production. When it was bought in the past. Matlab, example dekho. Say I took a land. I purchased a land and I purchased this for 1 lakh. Its value today is 5 lakh in the market. But what is the price at which I purchased? At 1 lakh. That is called its historical cost. And sunk cost is that cost which cannot be recovered. So, for example, if I just go ahead and I talk about the cost of advertising, I can't recover the costs I've spent on advertising ever. I can recover this land cost by selling it, but I can't recover the cost of advertising directly. So that becomes a sunk cost. But this is just a name of opportunity cost, that it is also called as transferred earnings. This is just what some authors call it. This is not transfer payment. Isko macro ke transfer payment se connect mat karna. This is just transferred earning, another name of opportunity cost. Okay. Then these are the curves that we should be well aware of. So your total fixed cost is constant. Total variable cost is first increasing at increasing rate, then at decreasing rate. Total cost is increasing at increasing rate, then at decreasing rate. In दोनों decreasing rate, then at increasing rate. इन दोनों के बीच का जो gap है, that is total fixed cost, right? When these costs are increasing at decreasing rate, then during that period, your average cost is decreasing. When they are increasing at increasing rate, then your average cost is increasing. So your average cost is U-shaped. Average variable cost is U-shaped. Your average fixed cost is downward sloping. Why? Because your average fixed cost is total fixed cost divided by output. So as your output will increase, your AFC will decrease, right? So AFC keeps decreasing. And because your AC is AVC plus AFC, so we can say that AC minus AVC is AFC. Now AFC is continuously decreasing. Therefore, the difference between these two will decrease. So we can just say that the gap between AC and AVC will keep falling. Will they ever intersect? No. Because intersection ke liye this should become 0 and AFC is never 0. So they will never intersect each other. No, sunk cost and fixed cost are not the same. Fixed cost is broader. Out of fixed cost, some can be recovered in the future, some cannot be recovered. The cost that cannot be recovered is the sunk cost. Correct, beta. AFC will be an asymptote. It can never cut the x-axis. AFC will always exist, right? But it will never be 0. So this is the concept of marginal cost, the additional cost incurred when you increase the output. Uske baad, you can just go through long run and short run cost. I don't think anything is important here. This is important and this can be asked in exam. Acha, now just think about it. Beta, aaj tak whenever we have studied variable cost is never sunk. Sunk cost is part of that cost which cannot be recovered. Variable is incurred only on inputs like labor, on raw material, etc. That is always recoverable. If I am not able to recover my variable cost also, then I will be in a loss. I will not do production. Now, beta, we have always studied that my AC is U-shaped. हमेशा यही पढ़ा है हमने. Now, there is something which is known as a modern theory. And this modern theory suggests that your AC is actually not U-shaped, but L-shaped. Modern theory ये suggest करता है that the AC is L-shaped. And the reason that they give behind AC being L-shaped is this three. So I want you to read this once. Just revise this once. It just says that your LAC, long run average cost, is not U-shaped. Rather, it becomes L-shaped. And these are the reasons behind this. Come below and just see here. There is something which is known as learning curve. The concept of learning curve was given by Kenneth Arrow. And he suggested that, as you go ahead and you keep producing something, it's like us. If you keep reading economics again and again and again, then with time, you will learn the same subject in lesser number of hours. Let's say you read your notes first time, it took you 1 hour. Second time, it will only take you 45 minutes. Third time, it will only take you 30 minutes. You will learn by doing. So same is the concept here, that if you keep producing the same output again and again and again, then with time, you will be able to produce the same output with lesser cost and with lesser inputs involved. That is because of learning by doing. And this concept was given by Kenneth Arrow. Now, this is the relationship between AR, TR, and MR. And just read this through. But this, ye wala jo part hai na, this talks about downward sloping MR and AR curve. That means this is talking about monopoly. Because if it is perfect competition, you will have constant AR and MR. No, beta, it is not economies of scale. Economies of scale says that if you double input and output, output will more than double. It doesn't talk about cost side. But this learning by doing says you are able to reduce your cost also. So it's a concept which also focuses on lowering the cost. Okay. Now, now there are two things. If I have perfect competition, then my AR curve is this. In this case, because you are a price taker, your TR curve will be like this. But if you have your AR curve downward sloping, matlab monopoly, it means your MR curve will be like this. In this case, your TR curve will actually have a slope. Your TR curve is no more a line, right? Yahan pe TR curve is price into quantity. Price is given and a constant. Say price ho gaya 2. So I'm just plotting 2 times Q. It's a line. It's a linear line, right? So your TR curve is just upward sloping line. But here, because your MR is continuously decreasing and your AR is decreasing, the TR curve that we plot is very, very different. It depends on how we plot the MR curve, right? So based on the shape of the MR curve, we get our TR curve. So if my MR curve is continuously decreasing, then my TR curve will increase, but it will increase at a decreasing rate. I hope you remember this from even class 12th, 11th. This is going to increase at a decreasing rate because of that reason, right? Because its slope is decreasing. Now, if we just go ahead and we look into this monopoly, there is something which is known as learner's index. And where we had gone ahead and we had proved that you can write your AR as MR E upon E minus 1. Now, in this case, just remember that whenever you will have downward sloping AR and MR curve, you can only go ahead and produce in this region. in the elastic region where elasticity of demand is greater than 1. Kyun? Because notice that, just try to notice that, this is my AR curve, this is my MR curve. When my MR is 0, if I just take that point to the AR curve, I will see elasticity of demand is 1. In this entire region, elasticity of demand is greater than 1. Now, where do I find equilibrium level of output? Where I will have an intersection of of MR and MC curve. So my MC curve will intersect MR curve somewhere here. यहाँ हो सकता है, यहाँ हो सकता है, यहाँ हो सकता है, यहाँ हो सकता है, यहाँ. यही कहीं MC curve रहा होगा, somewhere here. Let's say we take the lowest MC curve possible. I take this MC curve. Then, when I find the intersection of MR and MC, at that level of output, if I take it to the AR curve, I will still be in the elastic region. I can never be in the inelastic region because that will mean कि मेरे को intersection यहाँ कहीं negative में करना पड़ेगा, which is not possible. So, as a monopolist, you will always be going ahead and operating in your elastic region. You cannot operate in the inelastic region. This is what this curve is representing. Now, this is, yes, you're right. Learner's index and degree of monopoly power is actually the same thing. So, you know, the more the price I am able to charge over and above the marginal cost, the higher is going to be my power. And that can be shown as the difference. So, you know, I can just represent my power as P minus MC also, which tells me how much I'm able to charge over and above the cost. But in books, you will actually see this entire learner's index being used as the measure of the monopoly power. Okay. Now, there are some immediate things that you have to remember, and that is which you can see from the form of markets. So, यहाँ पे देख लो, you have perfect competition, monopolistic, oligopoly, differentiated oligopoly, and monopoly. In each of them, you should be able to distinguish based on number of firms, which go from large to 1. Type of product, it can be homogeneous or differentiated. Price elasticity, ये बहुत important है. This can come as an MCQ question. Right? Whether you have any price control or not, and whether there is free entry or exit. Just revise this table as it is. This is a very important table. Now, when it comes to perfect competition, you should know how to find out its shutdown condition in short run and long run. In short run, the aim of perfect competition is only to go ahead and cover its variable cost. So I will shut down if my price is less than average variable cost. But in long run, my aim is to cover total cost. So I will shut down if my price is less than ATC. This is my shutdown condition. In short run, I can have profit. I can have zero profit. I can have loss. But in long run, as a perfectly competitive market, I will always have zero profit. Zero profit is called as normal profit situation. Positive profit is called as supernormal profit. And negative profit is loss. Right? Loss may be, I am fine, I will continue working if my loss is only not covering the fixed cost. But if I'm not able to cover the variable cost also, then I will shut down. This is what these diagrams are representing. You need to revise these diagrams once. But abnormal profits mean supernormal profit only, na? This is what it is. Supernormal profit. Huh? So this is what the diagram is. Please revise supernormal, normal, losses, and long run equilibrium. These are some of the points to remember, and I want you to revise these points. Everyone should be revising these points. अच्छा, एक और चीज है इसमें. If I talk about producer surplus in perfect competition, then this is 0. There is no producer surplus. देखो ध्यान से. Producer surplus can be told as the difference between the price a producer gets and his cost, right? So costs se niche I cannot sell. The minimum I can sell is at my cost. So suppose I can sell at 10 rupees, but I'm able to sell at 20 rupees. So 10 rupees is my surplus. But for perfect competition, since price and marginal cost are equal only, there is no producer surplus. But the consumer surplus is maximum. Because the producer is charging minimum price possible, the consumer surplus is maximum. And how can I find consumer surplus? So to find the consumer surplus, you always will go ahead and find area under demand curve. Right? So if I have this as my demand curve given to me, and they tell you that the price charged in the market is 4 and the quantity is 3, and they ask you find consumer surplus. So this will be the consumer surplus. Area below demand curve, above price is the consumer surplus. Sometimes they will do this in exam. Just say, for example, they tell you that your demand curve is 10 minus say P, ऐसा कुछ दिया हुआ 10 minus P. And they tell you that when P is say 4, quantity is say 6, find consumer surplus. ऐसा कुछ दे दिया. Then I will first plot this demand curve. This will give me 10 here and 10 here. Then I will have P here and Q here. Now they have told me when P is 4, Q is 6. So when P is 4, Q is 6. So if they ask me find the consumer surplus, it means I have to find this area. Okay. So in this case, it seems very simple. You can just do half into base into height and find this area of the triangle. But suppose this would have been a non-linear function. अगर कुछ ऐसा होता, then this is not a triangle. Then what you will do is you will integrate your demand curve from 0 to 6, whatever your demand curve is, minus. You will subtract. So when you integrate any curve, you get the area under the curve. You will get this entire area. But to find consumer surplus, I only need this area. So I need to subtract this square. So you will subtract 4 into 6. This is what consumer surplus will be. So अगर ये ऐसा कुछ होता ना कि P is equal to 10 minus Q square, suppose ऐसा होता. And they would have said that when Q is 1, P is 9. And they would have asked you find consumer surplus. So कैसे निकालते? You would have integrated this curve from 0 to 1 because quantity is 1. And then you would have subtracted this 9 into 1. I'm not sure if you will get a positive answer here, but this is how you will do it. Okay. So the formula of consumer surplus is integrate the demand curve between 0 to the quantity asked minus find the area of the rectangle, which is simply P into Q. Always it will be P into Q. So minus P into Q. This will give you the consumer surplus. Okay. Then this is a general one. अगर ये demand है, ये supply है, तो area below the demand curve is consumer surplus. Area above the supply curve and below price is the producer surplus. Please read down the criticism. Read down the condition for monopoly. I have done this. Okay. Now, just like perfect competition, a monopoly can also have profit or losses. So this part is just saying that, if you look here, I can clearly see that I see that at this quantity, the price charged is this much and my cost is this much. So these become my super normal profit. I can have normal profit also, and I can have loss also. Of course, if it is a loss, a monopoly may want to shut down. Why will it operate under a loss, right? So that is what is shown here. Just read this through. I've explained this. Okay, fine. So I think I can stop here then. In the next class, I will take a final round of revision of microeconomics. I will start with discrimination among the monopoly. I will talk a bit about monopolistic competition, and then I will talk about general equilibrium, right? So this is where we can go ahead and end today's session. Okay, thank you. All questions I've written down, beta. Please go ahead and solve those questions. I will be posting them on portal by evening. And, you can go ahead and look into the solutions also. Show the diagram where CS and PS are equal to each other. It does not actually go ahead and represent any market. So only when the consumer and producer surplus will be equal to each other, only when we get exactly same area. So just try to think about it. This is P, this is Q. If this area that I have here, if this is exactly equal to this area, then my CS and PS will be equal to each other. But it does not represent a market. I cannot say that this represents perfect competition, or it represents monopoly, or it represents a particular case. No. In fact, for monopoly, बहुत cases में consumer surplus will be zero. For perfect competition, I've told you, producer surplus can be zero. So it does not depend. It does not say that it is of a particular market. The only thing is that if they are equal, ये दोनों triangle का area will be equal. That's it. It should not represent a market in general. But I told you, numerical sheet I will upload on the portal only. For POC, ideally, if they give you an option, they will give you that it can be of any shape. That will be the right answer to the question. It can be upward sloping, downward sloping, any shape.
Excuse me, ma'am.
Yes.
Ma'am, can't we say POC shape, it will be depending on the elasticity also?
It would, but I would not like to go ahead and just say that, because if you remember, whenever we draw these POCs, it depends on the substitution and income effect also, no? So I would not like to say just elasticity, but of course, how much am I going to increase the demand will depend on elasticity.
Ma'am,
I don't think we can go ahead and just say that. I mean, of course, quantity change ho price ki wajah se rahi hai, so we can say demand elasticity. But wouldn't it also depend on how much I change the demand of the other product? वो भी तो important है ना. So if you
yes,
go
ma'am.
ahead,
So if like elasticity is less than 1, and we know that price and total expenditure will fall or increase by the same direction only, so we can depict from the total expenditure that what will the quantity of the other good that we are demanding. So it can be upward also, downward also, or it can be horizontal also, depending on the elasticity. If we know about, if we get a hint about it, can we say that?
I don't think, I still think that income effect and substitution effect will have a role to play. The reason being that, so if I say that price of the good was earlier 10, right? This is PX. And I was demanding, say, 5 units of X and 2 units of Y, and price of good Y was, say, 5 rupees. Now, when price of good X decreases to, say, 5, there are two effects taking place. Substitution effect tells me to increase the demand of good X. Income effect tells me to increase the demand of both good X and good Y. Yahan pe it tells me to decrease the demand of good Y. So ultimately, my POC more than both are telling me to increase X. But my POC more than anything will depend on what happened with Y. If my income effect for the other board is more than the substitution effect, I may end up increasing Y also along with X. Then my POC will become upward sloping. If substitution income effect will be equal, then I will not change Y at all. Then in that case, my POC will become horizontal. And if my substitution effect will be greater than income effect, then I will end up reducing Y, in which case my POC will be downward sloping. So although I am talking about good X, but it is also the magnitude of good Y that will determine the shape of the POC rather than just elasticity. Because elasticity is just own price elasticity. But it should depend on how Y reacted to it, how I reacted for Y, good Y. Tab jaake it will tell me the shape of POC.
Ma'am, if total expenditure we can depict out that it would be less only.
Doesn't matter. See, total expenditure is the expenditure. जब हम expenditure method use करते हैं तो हम सिर्फ एक गुड की बात करते हैं क्योंकि वो प्राइस इलास्टिसिटी डिपेक्ट करता है, तो हम दूसरे गुड का एक्सपेंडिचर नहीं लेते. Whenever you are using revenue method or total expenditure method, वहां पे आप सिर्फ px into x करते हो and you check how this increases or decreases when px increases or decreases. Total expenditure में you will not take px into x plus py into y and then check how this changes when px changes. ये नहीं कर रहे होते हम. Total expenditure method is just to check the expenditure spent on good x when price of x changes. तो उससे मेरे को y के बारे में हिंट नहीं मिलेगा ना.
Okay, ma'am.
That would not be the right thing to say in this case. After JAM, there is only one month for CUET. So in that beta, the only thing that you have to do is do all these revision series. That is what is going to help you. Actually, I don't expect CUET में anything above the revision series. कुछ भी इनमें इसके ऊपर से आएगा. Do revision series, do question bank, do mock test paper. That is enough. Okay, I will just do EV and CV. Please explain Marshall-Lerner condition once again. So very simple, beta. See, Marshall-Lerner condition for monopoly na? You're asking for monopoly only na, Shivika? Okay. I thought kahin exchange rate ka to nahi pooch rahe ho. So just see here. See, I know that MR should be equal to MC. Now my total revenue is price into quantity. So marginal revenue is how total revenue changes as quantity changes. You will just differentiate this with respect to Q. So when you differentiate this with respect to Q, what will happen? Differentiation of first function, second as it is, differentiation of second function, first as it is. This will mean del P by del Q into Q plus P. Now what you can go ahead and do is take P common. So del P by del Q into Q by P plus 1. This is your inverse of elasticity. This will go ahead and give you P into 1 by elasticity plus 1. Remember here your elasticity itself is a negative value. It will be minus 2, minus 0.5. It will be a negative value. So then this is your MR. You have to equate this to MC. So your MR is equal to MC implies that P 1 plus 1 by elasticity is equal to MC. This is your Marshall-Lerner condition. Yahan se what you can do is you can also go ahead and say that P, you can also solve this further. So you can just take P on the other side. So you can also say 1 upon 1 by elasticity is equal to MC by P. You can also subtract with 1. So it will give you MC minus P by P. Right. And I told you now that this is a negative value. So if I want to bring this in absolute terms, agar mujhe isme positive value fill in karni hai, so I can just go ahead and say that I will multiply it with a negative sign so that this becomes positive on both sides and I will get this. So Marshall-Lerner condition says that P minus MC by P will be 1 by elasticity in absolute value. Correct. If total revenue and price move in the same direction, it is called as inelastic demand. That's correct.
So, ma'am, can you help me with the real life explanation of the Marshall learner condition? Because even when we understand through the mathematical approach and everything, it is difficult to connect it with the real life, and solving question becomes difficult.
Yeah, this is very simple and just real life to kuch bhi nahi. This is just a formula. So just think about it. See, if I just go ahead and tell you that I want to check what is my market power, how can I know what is my market power? My market power is basically how much price I can charge over and above the cost. So example, just take an example. If I tell you I am in a perfectly competitive market, perfect competition, I don't have any market power. So P and MC are equal to each other. So if P and MC are equal to each other, here I will get 0. 0 is equal to 1 by elasticity. This is possible when my elasticity is infinity. And that's true, that for perfect competition, you have perfectly elastic demand. Now, if I just start reducing the elasticity, reducing elasticity का मतलब क्या हो गया कि I am going towards monopoly. From perfectly elastic demand, I am reducing the elasticity. So take an example of, let's say, a person who is making COVID vaccine. He's a monopolist. There is no other competition there. Now for him, you will not have a perfectly elastic demand. For him, whether he increases price or decreases price, you will try to consume the same vaccine. So he can go ahead and increase in price and your elasticity of demand will be very low. You will still go ahead and purchase the same quantity. You will not reduce your quantity. So in such cases, when elasticity is low, then you have high market power. Matlab you can go ahead and charge a price over and above the cost. So this is just telling me that as your elasticity reduces, as this value falls, then 1 by elasticity will increase. Right? So as you go towards necessities, as your elasticity falls, 1 by elasticity increases. And when that increases, you are able to charge a price much more than the cost. You are able to act like a monopolist. That's it, that this is saying.
Okay, ma'am. Thank you so much.
Okay. Can we say substitution effect and elasticity are related? See, ideally, you remember the equation that we have derived for Slutsky. We can say that, but I will not say that, elasticity is exactly substitution effect. Remember that when I talk about elasticity, it tells me how quantity will change as price will change. So in a way, this is related to price effect. This is telling me the total thing, that as price changes, how my quantity will change. But when I go ahead and I talk about the substitution effect, this is telling me how quantity changes as price changes, holding utility constant at some level, right? So because I'm holding utility constant at some level, I can say that the substitution effect can be the slope of the compensated demand curve. This is telling me how quantity is changing as price is changing, holding utility constant. और ये generally बता रहा है कि quantity कैसे change होगी जब price change हो जाएगा. So this is a bigger effect, but this is a smaller effect in nature, right? So that way it is different. But whether it is competitive market or not, MR is always equal to MC at equilibrium. ये तो मेरी profit maximization condition है. My profit is equal to TR minus TC. So if I maximize my profit, I will get MR minus MC equal to 0. So I will have MR equal to MC only. The only thing that happens in perfect competition is that this MR is equal to P. So P equal to MC हो जाता है. But MR equal to MC is irrespective of the market. You will always have MR equal to MC. Nothing, उसमें कुछ अलग नहीं है.
Okay, ma'am.
BOGO scheme beta is when you get 1 plus 1. मतलब कि जैसे for example, if I tell you that good X का जो price दिया हुआ है, that is given to you as 10 rupees. But I tell you for every 1 unit of good X, you get 1 free. So if you are getting 1 unit free with 1 unit of good X, इसका मतलब ये हो गया ना that when you pay 10 rupees, you are getting 2 units rather than 1. So under BOGO scheme, In the real sense, the price of each unit of X is only 5 rupees. So BOGO scheme, you just divide the price by 2. That is how you find the price. How TR increases with P? TR will not increase when P will increase. I mean, I didn't get the question, sorry. If you have elastic demand, then we can say that TR and P move in opposite direction. If you have inelastic demand, then TR and P will move in the same direction. I was just mentioning that this TR beta, it should not be a guiding principle of the price offer curve. But this should not be used to see how your price offer curve will be sloped. That would be incorrect. What you were mentioning, right? That what one of you were mentioning, that is incorrect. वो नहीं होगा. We should be guided by substitution effect and income effect to answer that question. Okay, I think I've answered everything except compensated and compensation and that equivalent variation. Okay, let me take that question then before we end the class. So this is the question that I've given. Dekh lo ek bari beta. This says that individual 1A who works in city A and has to move to city B, and you're given the following information. You're given that income is 5,000 and utility function is this. And you're given that price of good X is 1 and price of good Y is 2. And then city B mein na price of good Y increases to 3. And it says find compensating variation. So in order to find compensating variation, what you will do, you will first find the initial condition. So dekho yahan pe, if I tell you utility is given as min of X plus 2Y, so I will have this as min of X comma 2Y. This is my utility function. Because this is a main function, I will have X equal to 2Y. My initial budget line will be price of good X into X, price of good Y into Y is equal to income. Price of good X is 1, price of good Y is 2, income is 5,000. So you will have X ki jagah pe you will plug in 2Y. 2Y plus 2Y is 5,000. So Y you will get as 1250 and X you will get as 2500. So your utility will become 2500 when you will plug these values. ये आपका initial case हो गया. In city A, your utility is 2500. अब दूसरे city में price has increased. Price has increased to 3. Compensating variation says I want the same utility as before. मुझे पहले जितनी ही utility चाहिए. So I will keep utility at 2500 and I will go ahead and I will just do min of X comma 2Y. This will give me X is equal to 2Y is equal to 2500. But I have to work with the new prices. And new prices 1, 3. So my new budget line will be Px into X plus Py into Y is equal to income. So X plus 3Y, price is 3 now, is equal to 5,000. Beta X ka value is 2500. No, not 5,000. Income I don't know. That is what I have to calculate. Sorry. X ka value is 2500 and Y ka value will be 1250. This will be M dash. So I will get my M dash as 2500 plus, how much will this be? This will be 3250. So it will be 5750. Just see the calculation if I've done it correctly. 3750, sorry. This will be 6250. So the change in income will therefore be 1250. अब देखो मैंने क्या किया एक बारी. ये तो basic case है. आपको income दिया हुआ था. You were given the prices. You found out your X and Y. And from that X and Y, you found out the utility. ये हो गया आपका initial case. Calculate utility based on your initial income and initial prices. ये initial case हो गया. Then it says that price of good Y has increased. So in budget line, you will use the new price. And at the same time, it is saying that utility has to be kept at the original level. जितनी उस consumer को पहले utility मिल रही थी ना, उतनी ही utility चाहिए. So I have kept utility at the original level. Holding utility at original level, but keeping new price ratio, I have calculated income. So what this income is telling me? This is telling me ki, look, if you want consumer to get same utility as before, but at new prices, you must give him 6250. Earlier you were giving him 5,000. So how much more should I give him? 1250. This is called compensating variance. So compensating variance tells me extra money you must give the consumer to get the same level of utility, but at the new prices. Okay, this is your compensating variation. I will just remove this from here because this is your numerical sheet. But I hope this is clear to you. Now, the second concept is of equivalent variation. In order to find the equivalent variation now, you must hold utility at the new level. Let me show it in other sheet. I don't want to spoil this one. So you must go ahead and hold utility at the new level. So now we are saying the amount of money to take from consumer. आप consumer से पैसा ले रहे हो, आपको उसको indifferent करना है सिटी 1 और 2 के बीच में. आप बोलोगे ठीक है, सिटी 2 में कम यूटिलिटी मिल रही है ना, तो ए की भी कम कर देते हैं, एक में इनकम कम कर देते हैं ताकि आप इंडिफरेंट ही रहो. So now what you will do is you will do the reverse process. You will start by finding the utility of individual in city B. और B में क्या prices थे? Price was 1,3. So you will start and say कि okay, the budget line of B will be x plus 3y is equal to 5,000. Utility function is x comma 2y. So 2y plus 3y is equal to 5,000. So you will get y as 1,000 and you will get x as 2,000. ये आपको x और y मिल गया. If x is 2,000 and y is 1,000, your utility that you will be getting will be 2,000. Now, holding utility at this 2,000, you will go ahead and calculate the income in the original bundle. So in original prices were 1,2. So holding original prices, you will calculate the income. It will come as 4,000. That means you will take away the 1,000 rupees from the consumer. You will only give him 4,000. So additional 1,000 जो उसको city A में मिल रहे थे, you will take it back. I hope this is clear to you. So when I am saying that, देखो दो चीजें कर सकते हैं. I have to make consumer indifferent between the two situations. अभी तक consumer को 5,000 यहाँ मिल रहा था. His price of good X was 1, price of good Y was 2. So first thing that I can do is, because here things are expensive, I can give him more money. ज़्यादा पैसा दे दो ताकि he is indifferent. Or because here things are expensive, so what I can do, I can take his income in this case. यहाँ से पैसा ले लो, so that he is still indifferent. The second approach is equivalent variation, where you are taking money from him so that he is indifferent. The first situation is compensating variation, where you are giving him money for shifting to city B. These two approaches are called compensating and equivalent variation. Okay, beta. Thank you. Then please practice this entire numerical sheet. There are some questions which are excellent here. Please do those, especially this one, where I have tried to use this rule now, that marginal cost can also be written as wage rate upon marginal product. Ye wale rules are new to you. So I want you to read this through and do these numericals before the next session. Okay, thank you.